Hello, welcome to this, my second presentation on doing integration by substitution. And the first one I did, part one, was dealing with the situation where the formula was linear. So for example, the x wasn't to a power, one of the x's wasn't to a power. In this one, we're going to be looking at where it is to a power. So let's have a look at this example here. So you can see we've got 4x to the power 3 times cos to the x to the 4. So how do we do this? Well, obviously it's a product, so we've got to do something with it. We've got to do something. We can't just deal with it in the same way we do with this if they were just summed. Okay, now the key in this is basically observation. So if you look at it, you'll notice that this x to the 4 here, if you was to differentiate that, you would get this term here, 40x to the 3, and that's the secret. So let's have a look. I think the easiest thing is to do an example, so let's have a look. So as before, we're going to let me put my pen on. We're going to designate something to be substituted with the letter u. So let u equal, and we're going to go for the stuff inside the bracket. Okay, because as you can see, that's when that's differentiated, we'll get that term there. So we're going to say x to the 4. So therefore, when I differentiate that, du dx, we get quite a simple differentiation for x to the 3. Okay, so like on the last video, we need to rearrange this to get it in terms of dx. So dx equals du divided by 4x3. Okay. So quite straightforward that. So let's have a look. So now we've got y equals differentiation of 4x3 times cosine, and we've substituted in u there, dx. Right, we want to do the derivative of this. If we did it as it treated it was, it wouldn't work, of course, because this is an x. But if we tried to deal with it, this would actually be a constant, so it would just disappear. So it's not going to work. It's not going to give the correct answer. So what we're going to do is we're going to change this term. So let's have a look. So if I substitute in again, should call this double substitution really. Okay, so we've got 4x to the 3 cosine u, and we've substituted in for dx, this term here. So we've now got du divided by 4x3. Okay, so you look at that, we've got something that will immediately cancel, so that will cancel with this. So we've just got the simple derivative of cosine of u, which is sine u. Be careful of those minus signs. There isn't a minus sign on this one. Plus c, don't forget the plus c. Okay, so if you're never sure about those minus signs, the best thing to do is do which the way you find easiest, which is usually to differentiate. So if I differentiate sine u, you get cos u, so I've gone back. That's always a good test. Okay, let's have a look. So we then need to substitute in for sine u, which is 4x3, x4, sorry, plus c, don't forget your c of constant. Okay, and that's it done. Obviously, if we were doing it with limits, then the c would disappear. Now, the interesting thing about this is you may or may not be amazed at the fact that it works, but it might give you a bit of a clue to how it works. That if we go backwards to test it, to see if we end up back at this one up here, so we do differentiation of that, you would have to use the chain rule. And if you do it, and if you want to do this for yourself, and it's a good exercise, then when you find it would end up back at that term, obviously the c disappears because it's a constant, it doesn't got an x. So you differentiate it and you'd end up back at this term here. Okay, so that's an interesting exercise. Let's just have a look at another one. So that was very nice because it became, we had a 4 at the front, so we had a 4 here, and they cancelled, and the X obviously to the 3 cancelled. What happens if we haven't got any numbers out front? Or what happens if it's a different number? Let's have a look. So if we look at this one, it's exactly the same principle. Let u equal the stuff inside the bracket, which is x to the 3. Again, you can spot that this is going to go, when we differentiate this one, in x to the 2, and that's x to the 2, so that's encouraging. So therefore du over dx will give us 3x to the 2. Okay, so let's take this on a bit. So x squared sine u, where we substituted in, dx, again wrong term, so we're going to substitute in 3 dx, and we get sine of u, come on, and that would be du divided by x squared, 3x squared, sorry, 3x squared. Okay, so again, these will cancel out, which is good because we want rid of the x anyway, because we're integrating in relation to u, and we've got this divided by 3. And the only thing I can say to that is, well, so what? It makes no difference. Let's move on. If I solve this, I get minus cos of u, and it's all divided by 3. Simple as that. It's just a variable at the front, not variable, a constant, coefficient. So it's not got an x, so there's no problem with it at all. It's not got another u either, so there's no problem with it. Don't forget your plus c. If I substitute back in for my u, we get minus cos, and that would be x to the 3 all divided by 3 plus c. So you can see it's actually, once you get the hang of doing it, it's quite an easy process actually. The trick to do is to look for that relationship, and what you're looking for is, does this other term, if it's the same as the term inside of the function but one less, i.e. what you get when you differentiate, you take 1 from the power, then you know it's going to work. It doesn't matter what numbers are in front, because you can work with those, you can work them out like we did with this one. Mostly they can just be ignored until the end, so it's nice and easy to deal with that one. And that's it really, just looking for that pattern. There's a few other clever little tricks to use with substitution, but we're not going to cover them at this point. Okay, so thank you for listening.